morning to all of you. Welcome to today's lecture on basic electrical system. In the lecture number 14, we will study the laws for the series circuit, parallel circuit, and Kirchhoff's current law. So let's start the lecture. As you know, in the earlier lecture, we have studied the applications of the series circuit in the automobile systems. Now there are certain laws which are fundamental in the series circuits. So what are these laws that we are going to see one by one? So law number one, it states that total resistance in a series circuit is the sum total of the individual resistances. The resistance values of each electrical load are simply added together. As you know, if you see this circuit, you can see here the total here the resistance of this system is around 2 ohms for this load, and here it is around I think 4 ohms. Here by mistake I have written amperes. Now if we sum up these two resistances, that is 4 plus 2, it becomes 6 ohms. So 6 ohms will be resistance of this circuit. Now law number 2. The current is constant throughout the entire circuit. If 2 ampere of current leaves the battery, 2 ampere of current return to the battery. Now here you can see by applying the Ohm's law, as we have calculated the value of resistance, we can get the value of current in the series circuit. The value comes around 2 ohms. So 2 ohms value comes around 2 amperes. Now this 2 ampere current will be going from the battery. Here we can see from this battery 2 ampere current is leaving. This will go to load number 1 and load number 2, and again it will return to the battery. Law number 3. Although current in amperes is constant, voltage drop across each resistance in the circuit. The voltage drop across each load is proportional to the value of the resistance compared to the total resistance. For example, if the resistance is 1/2 of the total resistance, the voltage drop across the resistance will be 1/2 of the applied voltage. The sum of the individual voltage drops equal to the applied source voltage. So this is similar to Kirchhoff's voltage law that we have studied in the previous lecture. Here are certain examples of the series circuit. Each of the 4 examples includes the following things. We have to find out the total resistance in the circuit, the current flow through the circuit, and voltage drop across each resistance. Consider this first example. Here you can see that the value of R2 is not mentioned. We have to determine the value of R2, that is the resistance in series with R1. We have provided the value of total voltage which is supplied to the system. Again, we have the value of the, we can say, there is a value of current and voltage. We have to apply we can say Ohm's law. By applying the Ohm's law, we can get what is the value of R2. So let's start. First of all, I will determine what is the total resistance of the system. How I can determine? By dividing the voltage by current. The value comes around 4 ohms. Now here, the value of one resistance, which is 3 ohms, is already provided. So from this, we can get the value of R2 that comes around 1 ohm. Now in this case, here instead of two resistance, we have provided three resistances in the circuit. Yeah, the current flowing through the circuit is also mentioned, that is around 2 amperes, and the supply voltage is around 12 volts. So determine what is the total resistance of the circuit. That comes around 6 ohms. So since the value of two individual resistances are provided, so the value of third resistance comes around 2 ohms. Now this is the unique case. In this, we have to determine the supply voltage. We have the values of individual resistances and the current flowing through the circuit. So we can sum up the values of resistances. That gives us R1 plus R2 plus R3, which is 3 ohms. Supply voltage, this 3 ohms multiplied by current flowing through the circuit. That gives around 3 in multiplied by 4 amperes is equal to 12 volts. These are actually the simple problems. These are framed to build up your conceptual understanding of this series circuit. Now here we have supplied the value of voltage and individual resistances. We have to find out the value of current. So by conventional method, we can get the value of total resistance, that is equivalent to R1 plus R2 plus R3. That gives us the value of 6 ohms. We have the value of supply voltage. If we divide this supply voltage by the resistance, that is the total resistance, we will get the value of current. That comes around 2 amperes. Now next upon the important circuit, that is called as a parallel circuit. In this parallel circuit, this complete circuit is having more than one path for the current. There are separate paths that are called as branches, legs, or shunts. The current flow through each branch or legs varies depending on the resistance in that branch. A break or open in one leg or section of a parallel circuit does not stop current flow through the remaining legs of the circuit. So this is the important reasons why the parallel circuit are more preferred in the automobiles as compared to series circuit. So if there is a problem in a one particular leg, that is not going to impair the other operations in the circuit. Now, the another important concept, that is the Kirchhoff's current law. So the Kirchhoff's current law, here it is applied to the parallel circuit. Here you can see the load number. Here this is a 12 volt battery which is connected to this 3 ohm bulb and 6 ohm bulb. Now we can see this is a parallel connection, means this point is connected to positive and this point is connected to negative. Similarly, in this case, it is connected to positive and negative. So the voltage across this and this will be equal since it is a parallel connection. But unlike the series circuit, the current which is flowing through each load will be different. Now here, so from this we can determine Ohm's law. Here we have given the value of 6 ampere. It is flowing through the battery. From this 6 ampere, 4 amperes will be provided for load number 1 and 2 amperes will be provided for load number 2. Here, the bifurcation of 6 amperes is based upon the value of resistance in the system or in the branches. More the value of resistance, less will be the supply current. As we know, the current always chooses the path of least resistance. So high amount of electrons or the current will be passing through the least resistance in the system. Here, the value of first this bulb is low. It is around 3 amperes. So here, the more electrons will flow through this branch as compared to this branch. So the sum of the current which is flowing through these individual branches must be equal to the current which is coming out from this battery. So this indicates the Kirchhoff's current law. I hope you have understood this concept. If any students finds any doubt, he can clear his doubt. He can simply drop me a mail, specify his doubt. So thank you for today. I hope you enjoyed the lecture.